See here now motion of a charge in magnetic field. Suppose you have taken here when the charge particle is projected perpendicular to magnetic field. So, here we can write when charge q is projected perpendicular to magnetic field. See here, there is a magnetic field like this. That means, what is the direction of magnetic field? It is inward to the plane of the paper, that is going into the plane of the paper. This is the direction of magnetic field. A charged particle is projected this side q with the velocity v. So, when the charge moved to this side with velocity v, so magnetic force is acting to this side, that is perpendicular. We can calculate by the right hand thumb rule, and also the direction of magnetic force is perpendicular to both magnetic field and velocity. So, the direction of magnetic force is acting to this side. So, because of this force, and this force is always perpendicular to the velocity, because of this charged particles move in a circular path like this. So, when the charged particle is over here with velocity v, magnetic force to this side. When the charged particle is here with velocity v, magnetic forces to this side, and when the charged particle is here, magnetic forces to this side. So, this charged particle moves in a circular path, and suppose the radius of the circular path is, we can take that is r. So, in this case we can calculate radius of the circular path, we can calculate time period, or that means the time taken by charged particle to complete one revolution, and also we can calculate its frequency. So, let us see here how do we calculate its radius. So, we can write here when the charged particle is moving in magnetic field, magnetic force and centripetal force is here equal, because the centripetal force is provided by magnetic force. So, we can write simply QBB is equal to mv square upon r. R is the radius, m is the mass of the charged particle, q is the charge of the charged particle here, and v is your velocity. This v we will get cancelled. So, we will be getting r is equal to mv upon qb. So, this is the expression for the radius of the path. We can also write here v is equal to qbr upon m. So, this is the expression for the velocity of the charged particle. Now, we can calculate time period. Time period is the total time taken by the charged particle to cover one revolution. So, we can write here velocity we know it and radius is known to us. So, we can write time period is equal to 2 pi r upon v. We can replace the value of r from here. So, 2 pi into mv upon v into qb, and this v will get cancelled, and 2 pi m upon qb. So, this is the time period of the charge which is independent of the velocity. Time period we have got. So, we can calculate frequencies also 1 upon t is equal to here qb upon 2 pi m. So, this is the expression for the frequency of the charge. So, this was the case when the charged particle was projected perpendicular to the direction of the magnetic field with velocity v. So, now in the second case, when the charged particle is projected, charge is projected at an angle theta. Suppose you have taken like these axes, this is x axis, this is y, and this is z. Magnetic field is acting to this side, and charged particle q is projected here with velocity v. When the charge is projected to this side with velocity v, this is here theta. It has got the two component v cos theta and v sin theta, and this charge is going like this. Because of v sin theta, charge is experiencing perpendicular force. So, it is moving in a circular path, and now because of v cos theta component, charge is actually displacing towards x itself. So, because of this, this path will become a helical path. So, here also we can calculate the radius, time period and frequency. So, here we can write QBB sin theta is equal to mv sin theta whole square upon r, because the perpendicular component of this velocity is responsible for the centripetal force. So, this and this will get cancelled. So, you will be getting r is equal to mv sin theta upon qb. So, this is for the radius. Now, we can calculate also time period in this case, and time period we will be getting here, that is t is equal to 2 pi r upon v sin theta. So, value of the r can be replaced. So, 2 pi upon v sin theta into mv sin theta upon qb. So, this is here v sin theta. So, again it is 2 pi m upon qb. So, this actually time period is similar to the previous case. So, the time period does not depend on the velocity here, and now we can get also frequency here. So, the frequency can be written, frequency of the revolution of electron, that is nu is equal to 1 upon t, that can be written here qb upon 2 pi m. And now after this frequency, we can also write this distance, that is called here the pitch, and this pitch can be written here. This is the horizontal distance that is travelled because of the v cos theta. So, we can write v cos theta into time period. So, it is here v cos theta into 2 pi m upon qb. So, this is about the pitch here. So, these conditions are here the motion of the charged particle in magnetic field in both the cases, when the charged particle is projected perpendicular to the magnetic field or it is projected at an angle theta with the magnetic field.